real exam questions. This is question 37 about struts and ties. Sketch the strut and tie model of the following structures. Use T for tension ties and D for compression struts. First one, here at the bottom, it's the pillar of a bridge loaded with 4 point supports. The double corbel of a beam with hollow core slabs, so you have 2 line loads, and a wall of an escalator on 2 foundation piles loaded with a uniformly distributed load. Let's start with the pillar of a bridge loaded with 4 point loads. We start with the easy part. This load will easily find his support in those 2 directions. So this is a compression strut. Same happens for this load. It can find easily the resistance at the 2 support points. On the right hand side, when this load is applied, there is no support here, so it's looking for the nearest support, so it will go to this support point. And the same happens on the other side. So that's easy. But now, where are the tension rods? This is not a mechanism, this is not a fixed mechanism. It's not stable. You need some triangles to form. On top, you have divergence of compression struts, so it means that there is tension because this will try to go outside and this will try to go on the other side. So this is tension. The same on this side. This is tension. And normally on this side, you will have 2 compression struts which are moving away, or it appears so. In reality, it's not, because this support is supported by 2 compression struts on both sides, so they will shorten this bar in the middle. So this is also a compression bar. On the bottom, we have divergence again of the compression strut, so this is tension, and there it's also tension. Now we look at the double corbels of a beam with hollow core slabs. We have the 2 line loads on it, but we do not have supports underneath. It's just a corbel. So it means the compression rod will start somewhere beneath the load, but where will it end? It goes down. There it will be joined by another compression strut. And now this hole must be put into equilibrium by a tension rod like this. This is again divergence of compression rods. And the whole system is supported by the beam, so these are in tension to hold up the load. So for a double corbel, you see that the bottom side is in compression and all the others are in tension. A wall of an escalator on 2 foundation piles and loaded with uniformly distributed load, which is this case. So we start with half of the load of this uniform distributed load is coming down here and it's coming down there. How far? It depends on the ratio H over L. So, but somewhere they will find the support. So that's also a compression strut, and this will also find the strut. The depth here, it is Z. It depends on H over L. These are 2 struts coming together, so it means it's also a compression strut there. Those struts want to go outwards, so it means there's a tension.